Hey there, so today we're going to be talking about the four pillars of object-oriented programming, and so we're going to be using a fun example with cars, specifically a Tesla, to make this easier to understand. So yes, there's four pillars, and the first one I'm going to jump into is called inheritance. So basically, we'll use an example on screen here. So inheritance is the ability for an object to inherit properties from another object, usually a parent object. And so in JavaScript, inheritance is a mechanism that allows one class or a constructor function basically to inherit properties and methods from another class. So it's a way of creating a new class that is a modified version of an existing class. So one example we can give here, by the way, if you're new to classes, I have an intro video to classes on the top right, so I'll link to that now. But let's just say that you have a class called a vehicle, right? Cannot spell today. And we'll keep it simple. For the constructor, we'll just put a make and model for the vehicle. And we'll do this dot make is equal to make, and this dot model is equal to model. As a quick refresher, if I were to say basically const new vehicle and set equal to a new vehicle, and I'll pass in, for example, a Tesla. We'll just say model 3. And I console.log new vehicle, you'll see we have a vehicle with a make of Tesla and Model 3. Okay. So what's going to happen is that, and let's just create a method here for it. We're basically, so this method will basically just return something. So we'll just say starting, and we'll say this dot make, this dot model. And sorry, as you know, if I were to console log new vehicle, and then call start engine and run this, it'll say starting Tesla 3. So actually I should just say model 3 to make it better here. So that's pretty simple, right? What's happening is the concept of inheritance is that we have this vehicle class, and let's just say that we want to extend, or we want to utilize this vehicle class inside of another class. We can use extends to basically do that. And so what's going to happen is that if I go outside of this class and create a new class here, so we'll just say class, and we'll call it, like, for example, electric vehicle, which extends the vehicle. And what we're going to do is we will say, again, constructor. We want to follow the same structure here. So we're going to go make, model, and then we're going to do battery. And so what we can do is that utilizing super, as we saw in that video that I made for classes, we can use super to basically access the properties of the vehicle. And so we can just pass in the make and model there. And then what we can do is that we can say this dot battery is equal to battery. And so basically, as you know, by using extends, we're able to access the properties of a vehicle and kind of import that into here. Made a mistake here. Okay, cool. So now if I instead do this new vehicle as an electric vehicle, so let's make this electric vehicle, and we want to do something where we pass in, Tesla Model 3, and let's just say that the battery percentage is like 75%. What's going to happen is now we can do something where we can actually access, instead of doing start engine here, if we do this, you can see we have the make, the model, and the battery percentage for this vehicle. So this makes our code a little bit more reusable, less dry, and because otherwise we'd have to rewrite this whole thing over and over. But now by using super, we have access to everything inside of the vehicle class. So hopefully this one wasn't too bad, because it's more of a review of what we talked about in the initial class video. So let's continue from here. So we're going to be talking about encapsulation next. So in a nutshell, or encapsulated, if you will, encapsulation is the ability to hide a object's internal state and functionality from the outside world. Now, when using encapsulation, typically what we're going to want to do is the properties that we have here, we're going to want to put an underscore in front of them. And basically that's signalizing to other developers that this is intended to be like a private type of property. And we don't want to make edits directly to this property here. We're actually going to use something called a getter and setter function or method to do that. And what I mean by that is that if we use the word get, if we use the keyword get, and then let's just say we create a method here just called make, and then all we're doing here is returning this dot, and now it's underscore make. what happens is that if I go to new vehicle here and I access .make, it will return Tesla. If I also do underscore make, it'll return Tesla. But the point is, with a getter function and a setter function, you can define some sort of functionality that you actually want. And so that functionality is actually hidden from the outside world. Let me give you an example of this. So let's just say, and this is just a very simple example here. So what I'm going to do is we're actually going to create a setter function, and we're going to try to set the make of the car to redo it. And basically what's going to happen is that we have to pass in the value, right? Because if we're going to set a new model, or a new make rather, we need to pass in a value. So we're going to pass in a value. And what's going to happen is that with this function, or method rather, we're going to basically say this dot underscore make is equal to the value that's passed in. And so what's going to happen is basically we can set something where if we do, and let me just take this out, if we do new vehicle dot make is equal to, and let's say we change it, right? So instead of a Tesla, it's going to be a Toyota, for example, right? So now if I console.log this new vehicle, you can see that the make is going to be a Toyota, right? If I also do underscore make, you can still see it's a Toyota. So what we can do here is instead create some more functionality where, let's just say by accident, we set this equal to an empty string. We don't want an object with an empty string because that's going to cause, issues in the future. We want there to be some sort of make for this car. So what we can do is inside of the setter function, we could do something where we can say, hey, if the value is greater than 0, so if the value.length is greater than 0, then what we can do is we can say, okay, this.make is equal to value. Otherwise, if it's not, so we'll say else, then what we want to do is throw, we'll just say like a new error, and we'll just say you cannot have an empty value for the make. So now when I go down, you can see for new vehicle make is equal to an empty string, I'm getting an error. You see it's throwing this error here. You cannot have an empty value for the make. So now I'm going to try to console log this. It won't go through because we're hitting an error here at this line. But if I put this back to Toyota, you can see now that I'm fixing that error. So basically, the point of these getters and setters is that it allows you to have some more functionality in terms of how you actually want to fix these things or make edits. And that's helpful because for let's say a junior developer, if you accidentally were to set this equal to an empty string and that causes errors in the code base, that can lead to big problems. But if we have a specific setter method for this make in this example, it helps to prevent that error from happening, which is great. It's important to note that in JavaScript there are really no true private properties like in other languages, but by using the underscore, it's considered private by developers. So in reality, it just helps because, again, like typically when you try to make a change to an object, you're not going to do like an underscore for that. And in that case, you can see it bypasses this issue. So you can do instead just the dot notation. And so let's put this back to Toyota, for example, right? So we have Toyota, and then of course for new vehicle, we can do dot make and it'll call Toyota. So what's happening is when you call new vehicle.make, it's using now this getter function to basically return the make. But you could create functionality here too. So you can say, for example, if this dot underscore make, just a random example here, is equal to, let's just say a Toyota, you could like console.log, that's a reliable car. So when you call this make, for example, it's really calling this function and it's expecting you to return, a value, of course, but you can add some extra functionality here, which is pretty cool to see. Okay, next up is polymorphism. What's happening is that polymorphism allows objects to take on multiple forms. So in JavaScript, this is achieved using an overriding method. So to make this simple, what we'll do is that, we have an electric vehicle here. So we'll just create a, also let me get rid of this new make stuff down here. Okay, So we're going to create a new class just called, I guess, gas vehicle. And we'll just change a couple things. So instead of this dot battery, we're going to say this dot gas is equal to gas. And I guess we'll use gas as like gallons, for example. And so you saw that like when let's just create a const gas vehicle, and we'll just set that equal to a new gas vehicle here. We'll pass in a Toyota, we'll say the, what's it called? The RAV4, I think. And then also the, we'll say like 5, no, that's not right. Let's just say, I don't know how many gallons it holds. I'm just gonna say 18 gallons of gas, right? And so, oh, I have to capitalize this 1 second. We're using super, so it's grabbing everything from the vehicle class up here. And so if I were to do, for example, console.log and then gas vehicle dot, and we'll do, what was the method? Start engine, right? So if I do start engine and call that, you can see it's undefined. Oh, that's because, right, I have to make a getter and setter because I changed this over to underscore model. So we'll do a similar thing. We'll just say, get model, and then we're just going to return this dot model. And then I'm not going to create a setter function because I don't intend to change the value. Okay, so you can see it says starting Toyota RAV4. Now that's coming because we're using super, and super is able to grab this start engine method from the vehicle class, right? But let's say we want a different one for electric vehicle and for gas vehicle. So we can literally use the same exact start engine method. And so we can override it, which basically means that we can create a new implementation of this method specifically for this subclass, which is under the parent. So instead of electric vehicle having the same starting Tesla Model 3, I could say, for example, I could return, and I could say, again, using template literal form, we could say something like, is starting up, and you have, we'll do this dot battery. You have this dot battery remaining. And so now, if I were to do, remember I put this on the electric vehicle, not on the gas vehicle. So if I were to do console.log and do electric vehicle dot start engine, run that function, you can see start engine is not a function. Sorry, I didn't mean electric vehicle. I meant new vehicle. Electric vehicle is just a class. I defined the new vehicle, which is a new instance of that class with all the information I passed in. So if I were to do that, you can now see that start engine, it says your Tesla Model 3 is starting up and you have 75% remaining. That meant 75% battery. So what's really important about this is that, if you have a whole bunch of vehicles, let's say you have electric vehicle, you have gas vehicle, let's say you have water vehicle, flying vehicle, whatever you have, it's going to be really annoying to say, okay, start electric engine, start gas engine, start air engine, whatever it might be. You want to just use like one type of method, right? Which is just start engine. So in this case, you can call the method without specifically knowing what class it belongs to, because each of these classes has their own iteration of what start engine is going to be. If it's just a vehicle class, then it's going to just say, hey, starting this, make this model. But for electric vehicle, you can use the same exact method, start engine, and get a completely different response. So that's great because it can override what was initially there. Okay, and finally, we're going to talk about abstraction. Now, abstraction is a little bit weird because it kind of relies on the concept that we're using classes like a blueprint to build out, subclasses that we actually are utilizing. So, for example, you have this vehicle here, right? And obviously, we have a start engine method here, which is returning, starting up this make and model, right? But what's going to happen is that when you start using more classes in your extending vehicle, if you don't create your own start engine method, it's basically going to utilize this template, type of thing here. So instead, what you can do here is you can actually say something like, you can throw a new error, and what you can say is like, hey, you forgot to create a start engine method on your class. And so what that means is that, for example, when we do the new vehicle, when we do the gas vehicle, right? We try to do start engine, it's going to throw an error because it's saying, hey, you didn't define a start engine method on your class. So it's grabbing that from here. But if I were to grab start engine and then actually put it inside of the gas vehicle, and then simply, instead of, it doesn't have a battery anymore, it's going to have gas. So you can say you have, 18 gallons remaining. Now you can see that it'll work correctly. So basically abstraction is like thinking, Vehicle is basically a blueprint for everything else. If I'm doing something more declarative like start engine returning this, I'm making it more declarative, right? It's no longer a blueprint. I'm actually saying, hey, I want you to return start up this make and model. So now you can think of the vehicle class as more of an abstraction of a real world vehicle, right? Like these are all the blueprints you need to actually create a vehicle. And it's basically saying, hey, like if you don't have a start engine method, then your vehicle is not going to work correctly. So you should be defining that. So it's using it more as a blueprint. And the actual electric vehicle is more of a concrete example of utilizing this class and it being implemented. So abstraction really is a technique of hiding these implementation details and showing only the necessary details over to the user. In this case, you can see that the vehicle class is only showing the necessary method start engine, but it's actually hiding the implementation of this method, which is then provided by the subclass, which is electric vehicles. I hope you found this video useful. If you did, please give a thumbs up and comment and subscribe if you haven't already. It really helps my channel to grow. And I will see you on my next video. Thank you.